Okay, we're on lesson 8.1.3 and we're going to now explore the angles of regular polygons. So in the previous lesson, we talked about what a regular polygon is. It is a shape that has the same size, the congruent size and congruent angles. So all sides are the same and all angles are the same. And then we also figured out what the sum of the interior angles are. So how many degrees does a pentagon add up to? How many degrees does a hexagon add up to? And now we're saying, okay, since all the angles are the same, you can find out what each individual angle inside is because they're all the same. So you simply divide by how many angles you have in that shape, right? So let's start with a little story here. Diamonds, a very valuable naturally occurring gem, has been popular for centuries because of their beauty, durability, and ability to reflect a spectrum of light, which is true. Yes, I often see when I'm driving, I see the light reflection off my ring. It's kind of fun, right? In 1919, a diamond cutter from Belgium, Marcel Tokowski, used his knowledge of geometry to design a new shape for a diamond called the round brilliant cut. It's quite beautiful. He discovered that when diamonds are carefully cut with flat surfaces called facets or faces in this design, the angles maximize the brilliance and reflective quality of the gem. So this is a picture of a round cut. It's actually really pretty. Notice that at the center of this design is a regular octagon with equal sides and equal exterior angles. So this is what we're talking about, this beautiful octagon in the middle. Okay. Determine the measure of each interior angle of a regular octagon. So without referring back to our notes from last time, how do I find out what the sum of the interior angle of the octagon is? Well, I remember a formula. The formula was taking the number of sides minus 2 times 180, right? So number of sides is 8 because it's an octagon, minus 2 times 180. So the sum is 6 times 180, which is 1080. Now, how many interior angles do we have here? We got 1, 2, 3, 4, 5, 6, 7, 8. So you take your sum, 1080, and divide by the 8 angles that you have to get that each angle is 135 degrees in this regular octagon. Okay? So what about interior angles of other regular polygons? Find the interior angle of a regular nonagon and then find it for a regular 100agon. So what we do is we're going to use that same formula of n minus 2 times 180 to get the sum of all of them, then divide by how many there are, right? So for a nonagon, that's 9-sided. So we go 9 minus 2 times 180. That will be 7 times 180. That gives me a sum of 1260. Then I take 1260 and divide by 9. And I get 140. So each angle of a regular nonagon is 140 degrees. Okay, we have our perfect 100agon from the last time, right? So what about 100agon? So I take 100 minus 2 times 180. That's your sum. So 98 times 180. The sum is now 17,640 degrees. And take 17,640, divide by 100 angles. All right, so divide by 100 angles. Each angle is going to measure 176.4 degrees. I don't know, have you noticed something? Your angle is getting bigger and bigger and bigger. It's getting really close to 180. Maybe that's a coincidence, maybe not. All right. Will the process you use for part A work for any irregular polygon? Write an expression that will calculate the interior angles of an n-agon. And we already did that in the previous lesson, right? The formula is take if n equals the number of sides, then the sum is equal to n minus 2 times 180. If we want the interior angles, we'll just take that sum and divide by n in the next step. Okay? All right, next problem. If all sides of a polygon, such as a quadrilateral, are equal, does that mean that all angles must be equal? If you can, draw a counterexample. So it's saying, if I have equal sides, does that mean all angles are equal? And you should know the answer to this. A rhombus. A rhombus has all equal sides, but all the angles are not the same, right? So I can draw a rhombus. And show myself. This is not very well drawn, but I try my best, okay? All right, so I'm gonna show the fact that, hey, this has all equal sides, but then the angles are not the same. So this is my counterexample, a rhombus. So congruent sides, not congruent angles. So one doesn't mean the other, right? What if all the angles are equal? Does that force a polygon to be equilateral? So can you have all the same angles but not the same sides? And again, you have the answer to that. It is a rectangle, right? If you have a rectangle, I'm exaggerating the sides. You don't have to have that long of a side. But if you have a rectangle, you know that all 4 angles are right angles. All the angles are the same, but my sides are not the same, right? So that's your counterexample, a rectangle. So congruent angles, but not congruent sides. Okay, so remember, one doesn't mean the other. So if you have both, that's when you can call it a regular polygon. You can have one or the other. One doesn't imply the other. Okay, all right. 26 here. Examine a regular hexagon. So we know it's a regular hexagon, meaning all the sides are the same. Then all the angles are the same too. Okay, so all the angles are the same. All right, very marked up here. So angle A is an example of exterior angle because it is formed on the outside of the hexagon by extending one of the sides. Are all exterior angles of a regular polygon equal? And take a quick look. All the exterior angles are linear paired to one interior angle, right? Here's the same angle A here. It's a linear pair to the interior angle. Here's that same angle A. So yes, they're all the same. They are linear pairs to the interior angles. So if the interior angles are the same, then the exterior angles must be the same as well, okay? So find A. How do you find A? Well, quick way would be to find the interior angle. We know based on last lesson that a 6-sided shape, a hexagon measures 720. And I believe one of the problem actually made you find the interior angle, but we can do that right now. We can go 720 divided by 6. So each interior angle is 120. So then I say 120 plus the angle A makes linear pair, so it makes 180. So my A is 60 degrees. Has to be 60 degrees, right? Because it's all linear pairs to every single angle that measures 120 degrees. This regular hexagon has 6 exterior angles as shown on the diagram above. What is the sum of the exterior angles of a regular hexagon? So if each A is measured 60 degrees, how many A's do I have? I have 1, 2, 3, 4, 5, 6. Okay, so I have 6 of them, each measures 60 degrees. 6 times 6, 360 degrees. 360, isn't that the measure of a circle? Again, coincidence, maybe. What can you determine about the exterior angles of other regular polygons? For each shape, find the measure of one exterior angle of the shape, and then find the sum of the exterior angles, all right? So one exterior angle. So an equilateral triangle, remember equilateral triangle? If you need to, draw yourself a picture, but each angle is 60 degrees, right? Because it's 180 divided by 3, so each angle is 60 degrees. And then the exterior angle has to be a linear pair. So I take 180 minus the 60 degrees. Each angle is 120. Right. Now, an equilateral triangle has 3 angles. Therefore, there's 3 exterior angles. So I take 3 times the 120. I get 360 for the sum. Okay. All right, a regular octagon. So we did that right up top here. A regular octagon. The interior angle is 135 degrees right here. That's part A of the answer. Okay, so each interior angle, is 135. So I take 180 minus 135 equals 45, oops, not 450, 45 degrees. Okay, so each exterior angle is 45 degrees. It's an octagon, so there's 8 of them. So 8 times 45 is 360. Is there a pattern here? So let's see. It was 360 for a hexagon up here. It's 360 for a triangle. It's 360 for an octagon. Maybe there's more, right? For a regular decagon, if you recall, it adds up to the sum of the angles 1,440 degrees. So divide by 10 because there's 10 angles there. So each interior angle is 144 degrees. So linear pair says 180 minus 144. 180 minus 144 gives me 36 degrees. Decagon has 10 sides, so 10 times 36 degrees. Wow, did we guess that? It's 360 degrees. Okay, and the regular dodecagon is a 12agon. So 12agon measures a sum of 1,880 divide by 12 because there's 12 angles there. So each interior angle, oops, one more time. Sorry, my mistake. It's 1,800. 1,800 is the total sum divided by 12. So 1,800 divided by 12. Each interior angle, the interior angle is measuring 150. So being a linear pair, it's 180 minus 150. Each exterior angle for a dodecagon measures 30 degrees. It's a 12agon, so 12 of them times 30 degrees gives me a total of, once again, 360. So compare the results from part D. Write a conjecture about the sum of exterior angles of polygons. I'm going to guess that the sum of the angles are always going to be 360, right? So the sum, me adding it all up, sum of exterior angles equal 360 degrees, always. Okay, all right. Use your understanding of polygons to answer the questions below, if possible. Okay, so first one says, Gerardo drew a regular polygon that has exterior angles measuring 40 degrees. How many sides does this polygon have? What is the name for this polygon? So think about what we did here, right? We did the number of sides times the exterior angle. That's always going to equal 360. We kind of proved that with this beautiful chart here in the previous problem. So we can use that to figure out what my number of sides is. So if I divide by 40 on both sides, that would tell me that the number of sides is really 9. This is 9 sides. And what's this called? It's a nonagon. Okay. All right. A polygon has an interior angle sum of 2,520. How many sides does it have? Okay, and the formula is taking the number of sides minus 2 times 180 to get the sum of 2,520. Okay, so let's see what I can do. I can divide by 180 first. I don't really have to distribute the 180. I can divide it by it first. So I get n minus 2 equals 2,520 divided by 180. That gives me 14. And then if I add the 2 over, I get n equals 16. So 16 sides. Remember, n is the number of sides. Okay? All right, boxing my answers. Next, a quadrilateral has 4 sides. What is the measure of each of its interior angle, right? So quadrilateral has 4 sides, right? So that measures 360 total. And there's 4 sides, 4 angles. So if it's dividing by, oh, I'm sorry, my mistake. And I think this is a very similar mistake that you would make too. It just says it's a quadrilateral. It doesn't tell me that it's regular. So I have no idea what the angles are. They don't have to be the same, right? Remember, it could be a parallelogram. It could be a non-congruent, non-parallel shape that is 4-sided. So I don't have enough information, right? I need to know more about it. Is it parallel? Is it a rectangle? Is it, what specific shape it is? So there's not enough information for this one. All right, that's okay, right? Okay, moving on. Next it says, what is the measure of an interior angle of a regular 360agon? Wow, is there more than one way to find this answer? Well, let's see. We figure that we need to find the sum first and then divide by how many, right? So we can go n is 360 because there's 360 sides. So 360 minus 2 times 180, that will give me my sum. So that's 358 times 180. It's a big number. My sum is 64,440. Then I take 64,440 divided by 360. All right, so each angle is going to be really, really big, 179 degrees. So that's how many degrees each angle is. Is there more than one way? You can go backwards. Yes, you can go backwards and say, okay, it's 360 agon. That means there's 360 sides. So that means then that if I use this idea and say, okay, there's 360 angles, I don't know what each angle is going to measure, but I know the total is 360. So if I divide it through, x equals 1 degree. So each exterior is 1 degree. Each exterior angle is measuring 1 degree. And we know that interior and exterior are supplementary. So I can take 180 degrees minus 1 degree to get 179. So that's the second way. Maybe there's a third way, but those are the 2 ways I know. Okay. All right. That's it, folks.